Hello and welcome to the very first episode of our podcast, Concrete Talks, where we explore innovation and performance in modern construction materials. In today's episode, we'll be diving into ultra-high performance concrete, or UHPC, a material that's reshaping how engineers think about strength and durability. Joining me today is Hamid Nefoussi, an engineering technical representative at MAPEI with a strong background in research and experience in field applications and real-world construction challenges. Together, we'll explore what makes UHPC unique and how it applies to North American infrastructure today and in the future. Welcome, Hamid. Thank you for joining us today.
Thank you, Melike. Thank you for having me. I'm really happy to this opportunity to give me the opportunity to speak and discuss the potential and the advantage of ultra high performance concrete here in Canada.
Thank you.
Thank you.
Before we get into the topic of the day, can you tell me a little bit more about yourself, your background, and your role at MAPEI?
Yeah, starting by my background, I have a civil engineering background. I did a bachelor and a master in design of reinforced concrete structure. I hold a Ph.D. on materials and structural behavior of different cementitious material like fiber reinforced concrete, ultra high performance concrete, under extreme condition by using different techniques. For my role at MAPEI, I work as an engineering representative with the specification team. So for the concrete installation system and structural strengthening system and solution and waterproofing membrane. So we work closely with the engineers to specify the right product that we provided with MAPEI and deliver different learning session. That's what I do with MAPEI.
That's very impressive. Can you tell me more about the types of projects you deal with at MAPEI?
For the type of project, there is no different type of projects for even for the new construction or for the existing building. We specify different solutions for the institutional building like school. Also for parking garage, we collaborate with engineer to specify the right system and the good strategy to repair and to protect the existing parking garage. And we work also sometimes for the existing building, dam water. We had also the opportunity to work for the heritage building.
Mm-hmm.
So there is different type of project, but I want to mention that we don't work only for the existing. Sometimes also for the new construction that the engineer they need to understand and to hear more about our solution. So yeah.
Okay. What kind of technical services does MAPEI offer besides just providing materials?
Yeah, I want to mention that I had the opportunity to work with MAPEI even before starting as an engineering representative for my old job. I collaborate with the team of MAPEI to do some repair strategy for the school, and I have seen the quality of the service that MAPEI provided for the designer. And for the engineer, we work closely. We deliver different learn presentation. Also, technical meeting related to the specific project. If engineers they need to understand or hear more about any solution, we can adapt our services to provide the right solution. Also, for the contractor, for the engineer of the contractor, we can collaborate with them also to find and to specify the right system. If they need some budgetary prices and to know more about the cost of our system. We can deliver this service. If they need some side job visits, we can provide it to we want to the site and to understand the real condition application, to see the service condition before suggesting the system. We want to work. We can work in the strategy or pre-designed phase with the engineer to understand the need of the clients and to see what is the main and the real causes of the deterioration. So we can provide this type of services to specify the durable and the right solution, and taking on consideration the durability, the price, and the risk. So this type of services that we provided, sometimes if they need also some revision and the specification, master spec specification, in certain condition or certain type of project, engineers sometimes they need the validation of their design. We can do calculation with our team to suggest our strategy with calculation. We do some analysis to provide and to suggest the right section or the right technology, because as I mentioned, so right, today we will talk about UHPC, but we have also FRP. That we can use it sometimes, and we provide different services to this technology. With MAPEI also, we have structural design software. So we sometimes we use it with engineer to study and to see the potential of different technology, and after that we can suggest the right and the best system to answer to the requirement to the clients.
It sounds like MAPEI really provides a lot of support, not only in the construction phase, but also the design phase and preliminary phases of the project. That's really impressive. Yeah.
Exactly. Yeah.
Okay. So moving on to the topic of the day, can you explain to us what UHPC means in North America and how it's differentiated from traditional concrete?
Yeah, I want to start by the engineering side of UHPC, or the designer side that we need to provide to engineer to do some design. UHPC, we need to achieve minimum 120 of compressive strength. Sometimes we can say to 150 MPa, but for me, UHPC is more than that. For mixed design, we need to add some selected fiber, depending on the specification and the need of the project. We can add different type of fiber. In general, we use steel fiber, but sometimes if we need some properties, we can add or do hybrid or two type of fibers, and which allow to the concrete to develop ductile behavior compared to ordinary concrete. If we achieve the maximum of its flexor strength, we will have brittle behavior, and compared to high performance concrete, when we achieve the maximum strength of our cementitious matrix, we can sometimes develop or get more resistance load. So for the durability performance, we have a very good resistance. Example for RCPT test, like the test that we use it to see the durability performance of concrete. We have less than 100 coulomb compared to ordinary concrete that we can be more or around 1,000 coulombs. And for the key parameters that we use it to define and to analyze the structural behavior of ultra high performance concrete, it's completely different. We speak for fracture energy. It's the parameter that control the propagation of the cracks, tenacity, intensity factor. Uh, Something that it's we don't use it for ordinary concrete.
Yeah.
That yeah, this like the difference. If we will speak for the material scale for the mixed design,
Mm-hmm.
also UHPC different. We have a high volume of cement, but also we add sometimes byproduct like slag or fly ash. We need also to add silica fume to reduce the porosity and to give a very low permeability of our matrix. And for if we speak for the water binder ratio, just an example here for the ultra high performance concrete, we say water binder, but for the ordinary concrete, we don't use this term, but use water cement ratio. For the value, for your HPC, it's around 0.18, but if for the ordinary concrete, it's around 0.45 or 0.50. So, which influence and control the microstructure of the concrete after that, and by the result, the durability and its behavior. So this, like, I think the main difference between this ultra high performance concrete and ordinary concrete.
I see. Is there a difference between ultra high performing concrete and high performing concrete?
Yeah. The main difference it is between the maximum compressive strength that we need to achieve at the minimum. For ultra high performance concrete, we need at least 120 MPa compared to high performance concrete. If they add some fibers, we need 80 MPa to 100. Also for the volume of and the quantity of the fibers. For high performance concrete, we can find or they use 1% of volume, which is equivalent to 78 kilogram per meter cube. Compared to ultra high performance concrete, we need at least 2% to 3%, which is equivalent more than 156 kilogram per meter cube. So there is also for the post-failure behavior or post-cracking behavior. For ultra high performance concrete, we said it's like hardening behavior. But for the high performance concrete, we see softening behavior. So I speak the curve, load displacement. If we do some flexor test, we see like for ultra high performance concrete curve like that. But if we see for high performance concrete, we see the maximum after that will decrease slowly.
Interesting.
Yeah, and after that, this parameter they control the behavior of the structure of your ultra high performance concrete. That's, for example, in the seismic event, ultra high performance concrete. It will give more time to the people to escape, and this give more time to before failure. So this type of parameters of difference that we can consider during design to compare high performance concrete and ultra high performance concrete.
Interesting. Okay. So have you come across ultra high performance concrete in your own research? Can you tell us more about that?
Yeah. During my PhD, and I want to get this opportunity to say thank you to all the person that helped me during my PhD, especially Professor Lashimi and Dr. Hussein Sayed, they give me the opportunity to work on this topic. And I studied the residual structural behavior and material behavior of ultra high performance concrete under extreme condition. We did it different tests after fire, and to see the potential of self-restoring and self-healing of ultra high performance concrete under extreme or after extreme condition by using only the watery curing. And we get it to very interesting results, completely different to what we was thinking. And
You had already mentioned that UHPC can be applied or used to retrofit structures or structural members. Can you give me some examples on how that's done and the approach that is taken?
Yeah. For example, if some client they want to change the use of the existing building, and they have a limited bearing capacity, they can use UHPC to improve the capacity and the bearing capacity of the columns. After that, they can add two levels and to change the use of the existing building. So we did it here in Quebec, and sometimes also if we need to improve and increase the capacity of the slab, and we don't and we have a limited space, we cannot use other technology. We can provide or choose and study the potential of your ultra high performance concrete to improve the capacity of our slab. Sometimes they use it also for the bridges to protect and to improve the capacity, the structural capacity of the existing bridges.
Would it be applied on the bridge deck or columns?
Exactly.
Okay.
Also in Italy, they use it for the heritage building and to repair or to sometimes, especially for the old building, sometimes they don't respect the seismic standard.
Yeah.
So that we can use ultra high performance concrete to improve the seismic behavior and the capacity of existing old building. So this type of or kind of application that we use ultra high performance concrete.
That's very interesting. Thank you for sharing that. So can you tell us about how UHPC is addressed in current North American codes and guidelines?
For Canada, there is no clear guideline or code for to the design and retroofing using UHPC. Sometimes they use US code like AASHTO code that they use it for the highway and bridges to design. And till now, for the new construction, the new version of CSA 6, they specify the use of ultra high performance concrete. But for the existing building, for the professors and researchers, they work on this topic to deliver or to make a Canadian code related to the use of ultra high performance concrete to retrofit or to improve the structural capacity of existing elements.
It sounds like Canadian engineers currently have to rely on international codes and existing research to design with.
Exactly. I had the opportunity and to discuss with here a Canadian engineer about this topic. They did it some design by using some European code. Switzerland, they have their own code to do design and structural design to do reparation or strengthening using UHPC. Also, Italian code is very good. do calculation. With MAPEI, we offer this service. Sometimes if engineers they need more information about this topic, we can deliver and provide some information and calculation designed related to this topic. But they work. I need that. I think I hope that the engineers they start to trust more and more on the use of ultra high performance concrete, because there is a huge potential that I think they they need to consider it during the pre-design design phase.
Absolutely.
Yeah.
So, like, the research is there, right? And it's just a matter of having faith in that research. In terms of research gaps, are there any that you see?
Yeah, but for me, it's not the professors here in Quebec or in Canada. They work on this topic every time. They use they study the behavior and they try to provide the new design method for retroofing or reparation existing or ordinary concrete using ultra high performance concrete. But the main point, as I said, the engineers they need to trust on this technology. Here with MAPEI, we try to do the link between the research technology and innovative technology with the real application. So yeah.
Okay, thank
Yeah.
you. What are some important factors to consider when installing UHPC?
Uh, there is different points on starting by the safety. So we need to consider these points with the applicator and the contractor. They should to protect the eyes and something really important to consider. Also, depending on the volume of the application, if we'll use if we want to pump UHPC, we need to follow some steps. With MAPEI, we developed our technical report related to this point, and we need to understand that UHPC we need at minimum 10 minutes of mixing, and to respect the order of the ingredients or the elements. Also for the if we need to we have a big volume of our slab that we repair it with ultra high performance concrete, and after that we want to pump to increase the or to reduce the time of our application. We need to use a special pump and with the mixer, and we need at least another mixer to mix and to pump in continuous our UHPC, because we cannot stop for the long period. Because if we mix the first part, we mix it for 10 minutes, we'll pump it I think for less than 3 or 4 minutes. So you cannot stop every time for the long period. So we need at least another mixer to reduce the time. And because if we stop for a long period, the ultra high performance concrete can start to react and influence also the quality of or change completely the quality of our product. Because only on this point it's not related to the quality of ultra high performance of our ultra high performance concrete. So we need to take this point on consideration during the application. After that, I want also to consider the surface preparation. Need at least minimum 4 or 5 CSP, and for the curing time or the curing technique, this is very important to consider. We need to choose the right technique, and we need to wait at least or apply at least 5 days of the curing time. It's very important to give the time to ultra high performance concrete to develop its mechanical properties and chemical reaction. So this, I think, the important point that the contractor that should consider it. And also with MAPEI, we did it some training days to contractor related only to the application of ultra high performance concrete, because the applicator they should to understand the nature and the nature and of ultra high performance concrete. It's completely different to the ordinary concrete. So we can deliver also sometimes some training to the contractor if they want to understand more about the application of this product.
For sure, for sure. So one of the ingredients of a UHPC mix are fibers, right?
Exactly.
Are there different types of fibers that are used in the mix, or is it standard?
Depending on the needs of the our application. So in general, they use the steel fiber, but also for the steel fiber there is different type, depending on the length or the diameter of the steel fibers, and also for the shape. And there is sometimes we have or we need to use steel fiber with anchor to increase the resistance and the transfer capacity of the steel fiber. And if there is any need or a specific application, sometimes we can combine some percentage with the steel fiber with some percentage of polypropylene fiber to make our ultra high performance concrete resist to the fire, or to prevent our ultra high performance concrete from the spalling during the fire. We need to add at least 1.5 or 2 kilogram per metric cube to prevent our ultra high performance concrete if there is any risk related to the fire.
I see.
Sometimes, we can use only steel fiber, but we can mix or do hybrid system.
Interesting. So I can already hear our listeners and or viewers asking this question, but how does the cost compare to conventional concrete?
I think it's not fair to compare ultra high performance concrete with at minimum 2% of steel fiber, which equivalent to 156 kilogram per metric cube. It's big quantity.
Yeah.
We compare to ordinary concrete. With the ultra high performance concrete, if we need to compare or do some economical analysis for the long term and the life cycle of ultra high performance concrete, and we compare to ordinary concrete, and we will see by far ultra high performance concrete is more interesting. I want to give only some examples of economical advantage of ultra high performance concrete. If we want to repair or retroofing slab or columns with ultra high performance concrete, we can remove the anchor. So this a factor that can influence positively the cost of application of ultra high performance concrete compared to ordinary concrete. If we will do some jacketing with the ordinary concrete, the first thing that we need to add some rebar, and after that we need to do some anchor to transfer the shear stress between the substrate and our concrete repair. So something that we don't need it in ultra high performance concrete. Also, if we speak on the thickness of the application for the ultra high performance concrete, we need less thickness compared to if
Yeah.
we do it with ordinary concrete. So we need to study all the system
Yeah.
and all the advantage, not only the cost of ultra high performance concrete compared to ordinary concrete. So it's not logic
Yeah.
to do this type
Yeah.
of comparison.
You're not
It's-
comparing apples to apples, and there's way too many factors in the mix.
Exactly. We need to consider for the long term and to compare the performance and the durability. If sometimes if we will use ordinary concrete, we need to protect it with a very good system from the aggressive or extreme condition. But if we use ultra high performance concrete, have a very low porosity and permeability, so it's very durable for the long term.
Yeah.
So I think it's really good to if we do some economical study
Yeah.
to
sure.
see the potential of different technology and what we will get it if especially for the long term, the advantage of different technology or different solution. So we can after that we can answer to this question, the cost of ordinary concrete
Absolutely, yeah.
compared to the ultra high performance concrete.
Okay.
Yeah.
Yeah, I think it's important just to explore all your options and doing that cost analysis first to see like how it could provide the most values, because it can be a better solution in the long term for sure in terms of durability, right?
Exactly.
My last question for you, looking ahead, where do you see the future of UHPC in the next 5 to 10 years?
Yeah, I'm really happy that some engineers here in Canada they started to consider ultra high performance concrete, and this is what we want to do with the MAPEI to increase like the demand and the specification of this technology or the use of this technology with engineer. I know the professor here in Canada they do the amazing and great job and to providing and delivering a good result and the research, but the engineer I think that they start to trust on this technology. Some engineer with the transport ministry they already started to specify the use of ultra high performance concrete for repair bridges, and I think it's really interesting. I'm sure that in next 5 years we will see the increased demand of or the application of ultra high performance concrete here in Canada.
Okay. Well, thank you very much for your insight. We really appreciate it.
Thank you.
And thank you again for tuning in. We'll be back with another episode on FRCM, fiber reinforced cementitious matrix. If you have any questions on the topic of FRCM, please reach out to me at m.celik@mapei.com and we'll be sure to address them. Until next time.